So we'll start with some questions from you guys. What do you guys got for me?
This is on worksheet 3.
Okay, worksheet 3. What do we want to talk about?
Could you go over like 0 or 4?
Hi, Mr. Coy.
Hi. He's in quarantine, so
he
he's not
is.
going to be here for a while.
Okay, thank you.
You're welcome. Okay. So first thing I'm going to do is I'm going to look for the midline because that's going to give me my K. So I'm just kind of doing that with my eyes. Appears to be -1 is my value for K. Then I'm going to find my absolute value for A, which is given by my amplitude. So that's the distance here. So going from -1 up to 2 is 3. And then we'll find our C. To do that, we need our period. So if I say here to here, we're going from pi over 2 to 3 pi over 2. So that's period is pi. And since the period is 2 pi times the absolute value of C, I know the absolute value of C is 1/2. And we're always going to use a positive C. So far, so good?
Yeah. So
Okay.
like for A, you're trying to find if that's positive or negative.
Yep, so we're getting to that. So last thing I need to do is determine my H and whether that A is positive or negative. So to do that, I'm going to use one of the extreme points because I'm dealing with a cosine function. So I could do either one. It doesn't really matter. For the sake of argument, I'm going to do that one. So in my parent function, I'm going to be using the point 0, 1, which is a maximum. And in my transform function, I'm going to use the point pi over 4, 2, which is also a maximum. Because going from max to max, that's the same kind of extreme point. That tells me the A is positive. And then because the x-coordinate from the parent function is 0, the H is just going to be the x-coordinate from the transformed function. And there's everything that I need.
And then, so if you're doing sin of x, would parent function be 0, 0?
So the point I'd be using is the midline point, which is 0, 0. And I'd be using the midline point from the graph. Okay. Sure. Mackenzie, I saw your hand. Worksheet 2, number 5. Okay. Where did my copy go? There it is. Okay. So it says construct a sinusoid with an amplitude of square root 6, a period of 7 pi, and a midpoint at 418. A midpoint and midline point are really the same thing. So the amplitude of square root 6 just tells me the absolute value of A is the square root of 6. The period being 7 pi tells me that the C is 7 over 2. Because again, we always pick the C to be the positive version. Not that we don't have, or not that we couldn't pick it to be negative, but doesn't make the problem any easier to do that. So let's just do that. And the next one, what we still need to come up with is the sign for A, and then the H and the K, right? Since we're told this is a midpoint, I'm going to use a sine function. So from the parent function, we're going to use 0, 0. And from the transform function, we're going to use the point 4, 18. Again, this is a midline point, and this is a midline point. From the parent function, the type of midline point we have is the one that goes minimum, midline point, maximum. So I just wrote that underneath. In the transform function, we're not told any information about the kind of midline point that is. So we're free to choose. Now, I would just pick it to be the same kind of midline point, because since those are the same, it makes the A positive. But if you chose them to be opposite, you could have an answer with a negative A in there. That's no big deal. Again, since the parent function x coordinate is 0, that tells me the h is just going to be the x from the transform function. And because the y coordinate from the parent function is 0, that tells me the k is just going to be the y coordinate from the transform function. And there's everything that we need.
You say again how you got y equals x?
I chose to do a sine function.
Oh, okay.
Because, well, all it asks for is a sinusoid. So it doesn't tell me it needs to be sine or cosine. It's just one or the other. I chose to do a sine because I had a midline point.
So what would you choose?
If you're given a maximum minimum, like number 4, then I would use a cosine function.
Why is that?
It makes finding the h easier because the y or the x coordinate is 0 for sine.
So then when is it easier to use?
So if I have a midline point, I'm going to use sine. If I have a maximum or minimum, I'm going to use cosine. Yep. And it just has to do with that point from the parent function that I'd prefer to use. I want it to have 0 in as many x or y coordinate places as I can. For sine, I have 0 in x and y for midline points. For cosine, I have 0 in the x coordinate for a maximum. It just, I mean, you don't have to do that. It just makes your life a little bit easier to do that. It's not like it's not doable the other way. It's just you have a little bit more algebra to do, a little bit more solving. Who's next? Or what's next? Alex?
Did you number 8 on worksheet 2?
Sure. Okay. It says find the equation of the sinusoid function that has a midpoint at 215 and the next extrema is at 8, negative 5. So I'm going to just kind of sketch a little bit of a picture here to get an idea of what's going on. So I have 215 and then 8, negative 5. So clearly that's a minimum, right? So like one period of my function is going to kind of look like that. Does that make sense so far, Alex? Okay. So the first thing I want to do is identify my midline point. So the midline point I know has to go through the midpoint. So that midline has to be y equals 15. because the y-coordinate for the midline point has to be the same as that horizontal line equation. So I know that k is 15. The next thing I'm going to do is find the amplitude, which is basically this distance. So if I go from 15 down to -5, that's 20 units that it's moved. And again, that's an amplitude, so it's absolute value. We'll figure out the sign for that in a moment. So far, so good. Next, I'm going to figure out the value for C. So to do that, I need to look at the period. So I know what I've drawn here is 1 period, but the piece that I know about is how much of a period?
1/4.
A quarter, right? So like you're a quarter, a quarter, a quarter, a quarter, right? Everybody's okay with that idea, that just kind of using our eyes? Which is why I drew the whole period initially. So I know 1/4 of my period is going to be the x from the right-hand side minus x from the left-hand side. So that's going to be 8 minus 2, or 6. So I have 1/4. And a period is 2 pi c is equal to 6. Everybody's okay with that? So I'll just multiply the 1/2, or the 1/4 and the 2. Multiply both sides by 2. Divide by pi, and then always going to pick my c to be positive. Ella? So yeah, you could say that 2 pi c is equal to 24. Yeah, absolutely. Yeah, that'd be the same as the equation that I had, just starting by multiplying both sides by 4, right? Which would be the same thing. Sure. Totally fine. You'll end up with the same value that I did there. Totally okay to do that. Alex, are we still doing okay?
Yeah.
Okay. So last thing we need to do is figure out the sign for h, or the sign for a and the value for h, right? So before we can do that, we need to choose whether to use a sine or cosine function. In this problem, it doesn't really matter because we have a midline point and we have an extreme point. So like either one of them is going to be pretty easy. Which one would you like to use? Okay. So if we use sine, from our parent function, we're going to be using the midline point 0, 0, which goes midline, or minimum, midline, and then max. From our transformed function, we're going to be using the midline point 215. That definitely went max, midline point min. Everybody agree with that? And how we came up with that?
Wait. No, because I don't. Oh,
Look at the picture I drew. Which is, again, why I start with the picture drawn, right? Because this guy's where we're starting. So it went from max min, or max midline min. Everybody kind of see that? Okay. So this tells me that the A is negative. And again, since the x-coordinate for the parent function is 0, the x-coordinate for my transform function should be my value for h. And then we just put it all together. Sure. So cosines from the parent function we're using 0, 1, which is a maximum. For my transform function, I have to use the extreme point, which was 8, negative 5. And that was a minimum.
Okay, so wait, why did you use a negative 5 this time?
Well, because I have to use an extreme point.
Okay, so any extreme.
So the extreme point I know
Okay.
is 8, negative 5, and I know that's a minimum from my picture.
I see.
So that tells me that the a is negative, and that my h is 8.
Okay. Okay, yeah, that makes sense.
So as I'm comparing answers, notice that the amplitudes are still the same. The sign on the a may be different, or it might be the same
Right.
from a sine to cosine. The h's should be different, but the k's need to be the same,
Okay.
and the c's need to be the same. Those things won't change. Maybe the sign on c could change if you really wanted to go down that road, but not the way that I've done it,
Gotcha.
or not the way I prefer to do it, which is just always having c be positive. Because there's always a correct answer where c is positive. So I'm just going to find one of those rather than worrying about like, oh, c could be negative, but a is positive, or a could be positive, and c
Yeah,
could
I
be
think that
negative.
one
You know,
will
like
happen.
it gets to be so many iterations that like, let's just fix one of these, and the c is the one. Like that kind of reflection is hard to envision in your head
Right, I see what you mean.
versus
Like,
just
it's always
the swipping.
positive, so I see it, right.
Yeah. Yeah. Mackenzie? Did you say 9? Okay. So pretty similar, right? It says find the equation of the sinusoid function that has a minimum value at 10, negative 20, and the second maximum value after that is 4618. So I'm going to start kind of the same way by drawing a picture. So I have here is my minimum, and then we have 1. So the second maximum is there. Everybody okay with that? Okay. The first thing I'm going to do is look for the k value. So the k value is related to the midline, which is going to be like halfway in between these two things. So that's going to be like the average of the y coordinates. So in this case, that's negative 1. Y max plus y min is what I wrote there. Right, but it's just the midpoint between those two y coordinates. It's just the average. So you just add them up. The amplitude is like half the distance between the max and the min. So that's going to be y max minus y min divided by 2. So it's going to be 19.
Would you say it was half the distance?
Half the distance between the max and the min,
Okay.
like vertical distance,
Oh, okay.
right? So I'm just taking the difference in their y coordinates instead of the sum. Mackenzie, still doing okay? Next, let's find the c. So if I look at this, I need to look at how many periods it is to go from the 2 points that I'm given. So I have one period is there. Agreed? And then this must be another half. Right?
What's the x, r, x?
Right and left. The x-coordinate for the point on the right minus the x-coordinate from the point on the left. Or you can just put an absolute value and just subtract the two x's. It doesn't matter the order if you put an absolute value around it. I'm somebody that would do something dumb and like forget to make the thing on negative and then be confused by what happened. Or like screw a sign up somehow or something. But so I just always take the one on the right and subtract it from the one on the left. Or you could do big minus small, like the bigger x coordinate minus the smaller x coordinate. You could think about it that way, and that's still doing the same thing. So far, so good? Okay. So 1.5 times the period, which is 2 pi c, should equal 36. 1.5 times 2 is 3. So if I divide both sides by 3 pi, I get that c is pi over 12. Again, we're choosing c to be positive, just like we always do. Mackenzie, are you happy with what we did there? Okay. The last thing we have to do is pick whether we're going to do sine or cosine, and then figure out the values for, or the sign for A and the value for H, right? So in this one, which would you prefer to use, sine or cosine? I wouldn't do sine. I would do cosine. Why? Because I'm given maxes and mins, right? It just makes, it's not like finding that H is that much harder if I use sine, but it's like, just makes it a little bit of a more of a hassle than it needs to be. And like, if I can just write down the value for H by picking sine versus cosine cleverly, I'd rather do that. You know what I mean? So cosine. So the parent function is the 0.01, which is a maximum. For my transform function, I have a maximum and I have a minimum. Does it matter which one I choose? No, I could use either one, right? Because they're both extreme points. Personally, I would probably pick the maximum. Because that tells me that the A needs to be positive.
You see, if you pick the min, would be still positive, right?
If I pick the minimum, the A would be negative.
Oh, okay. Because you're going.
You're switching the type of extreme points.
You're going up instead of down.
Yep. And that's everything I need.
The H is just the midline. The
The
K is just the midline.
The K is the midline, yeah. Again, lots of possible answers here. This is just one of them, right? Now, I did the problem in such a way that we found an easy to find one, but there's lots of answers here. Some of them would be, a little bit more of a pain in the tuchus to come up with, but not that much more. Happy, Mackenzie? Again, the trickiest part about that is coming up with finding the C, I think, in this case, where it's 1.5 periods. If you didn't draw the picture there, it'd be tough to come up with that without having a picture drawn. You know what I mean?
So if you pick the right parent function, then x on the transformation function should always be h?
Yeah. Yeah. In the problems that we've been given where the points are either midline points or max or extreme points, yes.
Are we going to ever deal with, like,
no.
just a random point? No.
Because then you don't know how to map it, right? Like, what point from the parent function should translate, or should this be turning from, or did it come from? Right. If you don't have that information, then like you can't really find the h.
Can't do it, yeah.
I mean, those very first problems on the first page where we don't tell you like what the point is, right? Like you could, if you really wanted to, you could say, oh, this point came from like 1/2 square root 3. Yeah. Like, I don't know why you'd want to do that, but you could pick like this point to go to some weird thing from the parent function and do that, but like it's just making the problem way harder than it has to be.
Right.
So you never have to do that kind of thing. You could, if you wanted to be like a masochist and make your work, make your life harder. But let's not do that, right? Our lives are hard enough.
Yeah.
I know mine is.
You do 4 just do number 3.
Yeah. So this one is relative, or should be relatively easy, but we went and did this thing to you and said you have to use cosine. If it's a sine one, it's like really, if I can use sine, it's really, really easy because I just pick -6, -9 to be a midline point, so it's automatically my h and k. And the a doesn't matter, the sign of it. I can pick either positive or negative because I don't know what kind of midline point that is. So that would be trivially easy. This one is a little bit more complicated because of that cosine requirement. So there's that. I know that the amplitude is 4 and the c is 2. And then I'm going to go ahead and say, okay, we're using cosine. So from the parent function, that cosine 0, 1 is a maximum. So in my transform function, -6, -9 is the point I have to use. I'm not told what kind of point that has to be, so I can choose what it is. I'm choosing it to be a maximum.
Because it's cosine, right?
Because we're forced to use cosine, yes. So that tells me immediately, since we're max to max, that the a is positive. Because the x-coordinate of the parent is 0, the h is -6. But finding the y now or finding the k is going to require a little bit of algebra. So I remember that to get the y-coordinate in the transform function, what I did is I took my a value. This is my stylus wants to write. I multiplied it by the y-coordinate from the parent function, and I added k.
Wait, why? It's the a is the amplitude.
Well, what our general transformation was this,
okay.
Right?
Yeah.
So what I'm doing to create these transform points to get the transform y-coordinate is I took the old y-coordinate, multiplied it by a, and added k. So that's where that equation is coming from there. I just put the subscript pf and tf in there to
I
kind
see
of
now, yeah.
really illustrate like what y are we talking about. So I just have 4 times 1 plus k should equal -9. So that just tells me k is what, -13.
And that's like what you do every time if you chose a cosine or when you should have chosen
Yeah, if you had chose a cosine when you probably should have chosen a sine, you'll end up having to solve this equation for either x or y,
Okay, gotcha.
depending on which one you
And
know.
if it's for h, then you just do cx plus.
Yes, exactly. Cx plus h. Yep, exactly. But that's the why if you pick the parent function,
That's wrong.
in the optimal way, you can avoid having to deal with that piece. But I mean, it's not like that's a hard equation to solve.
No.
But it's like, why would I do that if I don't have to, right? But if you don't care, then like, just be like, I'll do cosines for all of them. I don't care. Then that's fine. It's no biggie. You know what? What's up? Oh, with everything filled in? Sure. One more. And again, you could simplify things down in there a little bit, but distribute the half and turn the minus and negative into a plus sign. But like that stuff is trivial. I'm not going to worry about that too much, right? You guys are good on that, I would hope. I'm going to write it this way just so it's clear where everything's getting plugged into or whatever. You know what I mean? If I did all the distributing in your head and then you looked at it again later, you'd be like, wait, what? Where's this 3 coming from? Because there's no 3 as the h is not 3. But you get it. Now I'm just talking because it seems like it's quiet and it's a little awkward. I'm just trying to fill the void so that I don't get uncomfortable. Okay. Anyone else? And these are good questions to be asking. These are certainly difficult things the first time you're doing them. So if you're like, yeah, this was really hard for me, that's okay. This is kind of the hardest skill, I think, inside of this chapter. Once you get a handle on this is, I think as difficult as the skills in this chapter get. So that's, just as a, I don't know, to assuage your doubts, like, oh my goodness, this is only the first section of this chapter. It's like, no, this is the hardest thing in this chapter, I think. At least my experience as a teacher says that this is the thing that the students have the hardest time with. And I think it's just like kind of the most complicated thing because there's a lot of little crap to kind of have to worry about. Lots of little details that you're doing things for kind of like a geometric reason, not necessarily an algebraic one, with how we come up with some of these equations and how we decide if something's positive or negative. And, Paul?
Did you do number 7?
Sure. Where is 7? Okay. So this I'm going to do almost identically to number 9, right? Because it's almost the exact same problem. The only difference here is that instead of it being like the second maximum, it's just,
The first one.
yeah. So I have like, there. So I'm going to find my k the same way. So that's the sum of the y's. So y max plus y min divided by 2. So that's just 10. Find my amplitude the same way, which is y max minus y min divided by 2, which is also 10. That happens because the y min was 0, right? Next up, we'll find our c. So I notice that this distance is half of a period. So I have 1/2 of 2 pi absolute value c is equal to 20, or that c is just going to be 20 over pi. Again, choosing c to be positive. Paul?
So wait, just say again. So like K is the midline point, so like the middle of the two maximum minimum, and then A is the distance. It's half the distance from maximum.
Yeah.
Okay.
Yep, that's the way I'm thinking about it here. You could also think of A as the distance from a max or min to the midline.
Okay.
But if that's halfway, that's the same thing as half the distance between the two,
Yeah.
right? So either way of thinking about it is fine. I like doing halfway in between, or half the distance between the two, because then if I messed up my K, I don't get my A wrong.
Yeah.
Because I found the wrong K and I'm looking the distance from one or the other to the K.
Makes sense.
But it's still doing the same thing. Last up, we got to find our h and then pick our function, figure out where a is positive or negative. This one I would use sine or cosine.
I would use some maximum and minimum. I would use cosine.
Yep, that's what I want to use. So the parent function is 0, 1, and it's a maximum. My transform function, I can either use 3, 0 or 23, 20. It doesn't matter because they're both extreme points. They're maxes or mins. Let's this time, for the sake of doing something different, use the minimum. Since we've changed from max to min, that tells me that the a is negative. And again, the x-coordinate from the transform function is going to give us our h, because the x-coordinate on the parent function is 0. And that's all we need.
What's the y minus 10? No. I was looking at the
Yeah, the a value is negative 10.
graph are the same.
Yep. That's another good reason for me of picking them in. It's just so I don't, when you look back at it, it's clear which one was the K, where the K went and where the A went. Not that that's hard, but if you're just looking at it quickly, you're like, wait, what? Do we feel a bit better about these things after burning through a couple? You guys probably had a chance to try some by this point, so that also helps to go through things, having played around with it a little bit. Paul?
Did you get 20 from again? Or when you had half the XR?
23 minus 3?
Oh, okay.
Okay.